So good morning. Today's topic is organic reactions. If we talk about the organic reactions, there are three types: substitution, addition, and elimination. Just to differentiate between these three types of organic reactions, let us take an example. Like the students are sitting in the class. If one of the student is asked to go out and in place the another student from the outside comes and takes his position, it is called the substitution. That is, the group or the atom which is already present on the carbon of the organic compound is allowed to leave and in place some other comes in that place. So this is called the substitution reaction. That is the substitution of the already existing atom or group by some another atom or group. Then comes the addition reaction. Addition, some group or the atom is added to the existing organic compound. Elimination, the existing atom or the group is eliminated, removed from the organic compound. So these are the three basic types of organic reactions. Let us start with substitution reactions. If we talk about the substitution reaction, then the group which is leaving the compound is called the leaving group, and the group which is coming in place of the leaving group is either the nucleophile or the electrophile. Nucleophiles are the groups which are electron rich, which have electrons to give, and electrophiles are the group which are electron deficient. That is the group which attacks the position where there is the availability of the electrons. So depending upon the type of the organic compound in which the substitution is taking place, it is aliphatic and aromatic. Let us first discuss the aliphatic substitution reaction. So as I have just said, if the incoming group is nucleophile, it is called the nucleophilic aliphatic substitution reaction. And if the incoming group is electrophile, it is called the electrophilic substitution reaction. Then, depending upon the kinetics of the reaction, each of the reaction is of three types. One is unimolecular, second is bimolecular, and the internal nucleophilic substitution reaction. So if we talk about the abbreviation, it is SN reaction, it is SE reaction, that is nucleophilic substitution and the electrophilic substitution reaction. If it is unimolecular, it is called SN1. If it is bimolecular, it is called SN2. And if it is internal, it is called SNI. So these are the abbreviations which are used for the different types of nucleophilic substitution reactions. Similarly, the aromatic substitution reactions are also of two types: nucleophilic and electrophilic. So let us first start with the substitution reaction, in which we will discuss what is substitution reaction, how many types are there, that is what are SN1, SN2, SNI reaction. Then in each type of the substitution, nucleophilic substitution reaction, that is SN1, what is the mechanism, what is the stereochemistry, what are the different factors which are affecting the rate of the reaction, and the potential energy diagram of each of the nucleophilic substitution reaction. So, in the substitution reaction, as I have already said that the two types are there, nucleophilic and electrophilic. Let us start discussing with the nucleophilic substitution reaction. As I have just told, it is of two types, SN1 and SN2. It is unimolecular nucleophilic substitution reaction, and this is bimolecular substitution nucleophilic substitution reaction. This unimolecular and the bimolecular terms, it depends on the kinetics of the reaction. Kinetics means the rate determining step of the reaction. In the case of SN1 reaction, in the rate determining step, only one molecule is there. That is why it is called unimolecular. And here the rate determining step depends on the concentration of two molecules. That is why it is called the bimolecular nucleophilic substitution reaction. Now let us start with SN1 reaction. What is the mechanism of SN1 reaction, that how it takes place? Then we will discuss the stereochemistry of this SN1 reaction, then the different factors which are affecting its rate, and then the potential energy diagram. So, unimolecular nucleophilic substitution reaction. What is it? Let us consider its mechanism and explain it by taking one example. Let us take this example. This is alkyl halide. This halogen, halide group, this is the leaving group. That is the group which has to leave or which will be replaced by the nucleophile. Then in the first step, this is called step 1, and this results in the formation of carbonium ion. That is, this leaving group, as it is more electronegative as compared to that of carbon, so we can say that this bond pair of electron, it will be strongly attracted towards the halide, and this halide will be finally detached from the carbon, resulting in the formation of carbonium ion. This is the carbonium ion, or we can say it is the intermediate, reaction intermediate. After detachment, the halide, it forms a stable anion. This step is the slow step, and the slow step is always the rate determining step in the kinetics of the reaction. Then in step 2, what happens? There is the attack of the nucleophile on the carbon bearing the positive charge. This is step 2, and step 2 is the attack of the nucleophile on the carbon of carbonium ion. Then finally, there is the formation of the product. We can say that the substitution product. This is the substituted product in which the halide, which was previously taking one of the position, is replaced by the nucleophile. So this is the mechanism of the unimolecular nucleophilic substitution reaction. This is the simplest step. If we take the particular nucleophile, then one more step will be there, and that will be the last step, deprotonation. Let us take an example and explain that part also. Here we will go stepwise, that is step 1. And this step 1 is formation of carbonium ion. So let us take this example of the tertiary alkyl halide. X is there, which is the leaving group, being more electronegative, this bond pair of electron, it will be strongly attracted towards the halide, and finally the halide get detached from here and it becomes a stable anion, thereby forming this carbonium ion, which is bearing the positive charge. This is the reaction intermediate, and this is the slow step. Slow step is always the rate determining step. And here in the rate determining step, as only one molecule of the alkyl halide is involved, so it is the unimolecular reaction. Then step 2. Step 2 is the attack. As I have just explained, attack of nucleophile on the carbon bearing the positive charge. So let us take this example. This is the carbonium ion which is formed in the first step. So if it is attacked by water, in water the oxygen is having the lone pair of electron. So this water will get attached to the carbon bearing the positive charge through the oxygen atom, because it is the electron wanting and the oxygen is having the lone pair of electron to donate. So the structure will be like this. As one lone pair of electron is lost in making this bond, so there is the deficiency of electron over the oxygen, so it will become positively charged. This is one of the unstable intermediate. In the next step, that is in step 2, in step 3, which is the deprotonation, that is removal of a proton. D means removal, protonation means proton. So the structure which is formed in step 2, from here, this one proton, it will be removed by some deprotonating agent, and the resultant is this compound, which is the substitution product. So if we talk about unimolecular nucleophilic substitution reaction, the 3 steps are involved in the mechanism. The first step is the formation of the carbonium ion, in which the halide of alkyl halide being more electronegative, it will attract the bond pair of electron towards itself and get removed from here, become stable anion, thereby forming an cation, that is the carbonium ion, in which the carbon is bearing the positive charge. This is the slow step, so it is the rate determining step, and as in the rate determining step, only the concentration of one of the molecule is altered, so it is called the unimolecular reaction. Then step 2 is the attack of the nucleophile on the carbon bearing the positive charge. There is the formation of an intermediate unstable compound, and by the deprotonation, this unstable intermediate compound get converted into the substitution product. So this is the mechanism of unimolecular nucleophilic substitution reaction, which is taking place in the aliphatic organic compound. Now the next is the stereochemistry of SN1 reaction. First, let us talk about the stereochemistry. What is the stereochemistry? Stereochemistry, if we talk about the organic compound, it is the study of the 3-dimensional structure of the organic compound. But if we talk about the stereochemistry of a reaction, so it is how the leaving group is moving, how the incoming group is coming, like the path or the way which is followed by the reaction to take place, or the orientation of the different atoms or the groups. This is called the stereochemistry of the reaction. Now if we talk about the stereochemistry of SN1 and we are asked to explain the stereochemistry of SN1 in one step only, in single word only, then how can we explain it? It can be explained by using the term racemization. So racemization is the single term which is enough to explain the stereochemistry of SN1 reaction. How? Let us see. So this is the alkyl halide which is undergoing the SN1 reaction. As we have discussed in step 1 of the mechanism, there is the removal of the halide. So there is the formation of carbonium ion bearing the positive charge. Now in the next step, as per the mechanism, this carbon is to be attacked by some nucleophile. And the stereochemistry of this particular SN1 reaction will explain the direction from which the nucleophile will approach this carbon on which it has to attack. So if we talk about the nucleophile, it can attack on the carbon bearing the positive charge from this way, and it can also attack the carbon from this way. Like this is the pathway 1 to attack the carbon bearing the positive charge. This is the pathway 2 which is followed by the nucleophile to attack the carbon bearing the positive charge. So there are the 2 possibilities, 2 directions by which the nucleophile can approach to attack on the carbon bearing the positive charge. Now let us see what will be the tentative products as per pathway 1 and as per pathway 2. So this is pathway 1. In the pathway 1, the nucleophile is attacking from the back side of the carbon. So what will happen? All the alkyl groups which are present on the carbon, they will get shifted slightly away from the nucleophile like this. And there is the formation of the substitution product, in which the halide is being substituted by the nucleophile, and the configuration of the product is just opposite to that of the reactant. So we can say it has inverted configuration. If we talk about pathway 2, that is, if the nucleophile attacks the carbon of the substrate through pathway 2, then the resultant product, it will be in this, the configuration of the product is same as that of the reactant. So we will say that this is the product with retended configuration. This is the product with retended configuration. So, as per the stereochemistry of SN1 reaction, the nucleophile, it can attack on the carbon of the substrate from either sides, and resulting in the formation of the inverted configuration product or the retended configuration product. And it has been observed that both the types of the products are formed, out of which the product with inverted configuration is the major product, and the product with retended configuration is the product with retended configuration is the major product, and the product with inverted configuration is the minor product. As there is a formation of the two products of opposite configurations of different configuration in the form of a mixture, so this mixture is called the racemic mixture, and the phenomenon is called the racemization. So in this way we can say that the stereochemistry of SN1 reaction, it can be explained by this single term, racemization. That is, in the SN1 reaction, there is the formation of a mixture of two products. One is with inverted configuration, one is with retended configuration. The concentration of product with inverted configuration is less as compared to that of the product with retended configuration. So it is the example of racemization, and the mixture of these two products formed is the racemic mixture. Now let us discuss about the different factors which are affecting the rate of SN1 reaction. There are three factors. Number one is nature of the substrate. Here in SN1 reaction, the substrate is alkyl halide. Second is the effect of the leaving group, that is the halide group. And nucleophile also. And the third is the effect of the solvation. Let us explain the effect of these three factors one by one. First, let us take the effect of the nature of the substrate on the rate of SN1 reaction. The substrate is the alkyl halide. And to explain this, let us take an example. This is the alkyl halide. In the very first step, that is in the rate determining step, this halide has to be removed from here, and there is the formation of the carbonium ion. Then the further reaction, it will depend on the stability of this carbonium ion. If it is stable, then it will wait enough for the attack of the nucleophile over it to give the product. But if it is unstable, then before the approach of the nucleophile, it tends to get decomposed. So here, the stability of the carbonium ion, it affects the rate of further reaction. So if we talk about the stability of the carbonium ion, then here are the structures of tertiary, that is 3 degree, primary, secondary 2 degree, and the primary carbonium ion. Here the tertiary carbonium ion or the 3 degree carbonium ion, it is supposed to be the most stable. That is, if we take the tertiary alkyl halide, then it will favor the reaction most. Why? What is the reason behind? We can say that the reason behind is the stability of the tertiary carbonium ion. Then the question comes, what are the reasons behind the stability of the tertiary carbonium ion? Then the two reasons are there for this. One is hyperconjugation, also called no bond resonance, and the second is the positive I effect, that is the inductive effect. Positive I effect or the inductive effect. These two are the we can say the reasons, or these two are the processes or the phenomena by which the positive charge which is present on the carbon, it get equally distributed over the other atoms. And any process in the system which is bringing the dispersal of charge is supposed to stabilize the system, and any process which is bringing the concentration of charge over a point, it is bringing the instability in the system. So following this, we can say that the hyperconjugation and the positive inductive effect are the two reasons behind the stability of the tertiary carbonium ion or the 3 degree carbonium ion. That is, by these two phenomena, the positive charge which is present on the carbon, it get equally dispersed over the another carbon atom. That is the effect of the leaving group or the nucleophile. Leaving group. The leaving group should be good. Now, what is the definition of good leaving group? What is the good leaving group? अच्छा क्या होता है? The good leaving group is the group which is able to form the stable anion after the detachment. So we can say that the halide which is present in the alkyl halide, if it is more electronegative, then it will have the more tendency to form the stable anion after getting detached from the parent compound. Then comes the nucleophile, the stability, or we can say if the nucleophile has electrons to give, then it will be more interested to move towards that point where there is the need of the electron. That is why the nucleophiles which are bearing the negative charge, they tend to attack on the carbon bearing the positive charge. Then comes the solvation. What is solvation? For any reaction to take place, the medium is required. That medium is provided by the solvent. And obviously, the solvent affects the rate of reaction. Now, let us study that what is the effect of solvation on this SN1 reaction. The SN1 reaction is involving the ionization. That is, in the very first step, there is the formation of the cation and the anion. Cation is the carbonium ion and anion is the halide ion. So, if the solvation or the solvent, it is promoting the ionization of the compound or the reactant, then it will automatically favors the rate of reaction. So, here we can say that the rate of SN1 reaction, it is effectively directly proportional to the solvation. Now, the next is the potential energy diagram of SN1 reaction. It depicts the change in the potential energy as the reaction proceeds, and it can be explained by plotting a graph between the potential energy and the rate of reaction, SN1 reaction. The curve, it will be like this, consisting of A, B, C, D, E. These are the major change points. At A, this is the alkyl halide. At B, in the alkyl halide, the bond between carbon and the halide starts breaking. That is, there is the formation of an intermediary unstable state. At C point, there is a formation of the tertiary carbonium ion, which is supposed to be stable. Then again, the nucleophile will start approaching the carbonium ion, and there starts the formation of a new bond between the nucleophile and the carbon. This is also the unstable intermediary state, and finally there is the formation of the substitution product. So this is the potential energy diagram for SN1 reaction, and the various stages and the associated the potential energy amount, it can be shown by this curve.